What's up, everybody? In this video, we're going to learn how to do prefix sums. So first obvious question is, what is a prefix sum and when would I want to use one? In a lot of these problems, you're going to run into situations where you're going to be asked to analyze something about a subset of data, or potentially multiple subsets of data. For example, I've got here a list of numbers. Let's say like our goal is to find out whether or not a certain sequence adds up to 11. Perhaps the problem is asking you to find out how many times there is a subsequence that adds up to 11. For example, here is 3, 7, and 1 that adds up to 11. Here's 2, 6, and 3 that adds up to 11. There's a lot of different sequences that add up to 11. So in any situation where the question is either A, do indexes 2 through 5 add up to 11, question mark, and you have to go analyze those indexes and find out whether or not that's the case, or how many times, what is the number of times that a subsequence adds up to 11? And you end up having to check all kinds of different subsequences, like, okay, what about here to here? What about here to here? What about here to here? What about starting from 2? We need a quick way to do this. So that's where prefix sums comes in. What a prefix sum is going to do is it's going to give you the ability to look at a subset of the data and to know in constant time rather than linear time whether or not it adds up to 11. So for example, let's say like the question was, and it might not always be 11. Maybe maybe one of the questions is to locate a site where it adds up to 11, and then the very next query is to locate a site where it adds up to 20. Anytime we are repeatedly querying this data. So for example, let's say like the question was just to find out what the total is for a certain set. So I want to know, okay, from indexes 1 through indexes 6, what is the total? That would be 1, 2, 3, 4, 5, 6. Now, ordinarily, I would have to add all these numbers up. 2 plus 6 plus 3 plus 7 plus 1 plus 3, which is fine. But let's say like the very next query is, what about 2 through 7? What does that add up to? What about 2 through 5? What does that add up to? Now, you'll notice that if we're doing that, we're repeatedly checking and adding the same indexes more than once. When we do 2 through 7, we're going to do 6 plus 3 plus 7 plus 1 plus 3 plus 4. When we do 2 plus 5, we're going to do 6 plus 3 plus 7 plus 1. What was that? 1, 0, 1, 2, 3, 4, 5. Yeah. Now, this is a lot of repetitive calculating because I've added 6 3 times, I've added 3 3 times, I've added 7 3 times, and I've added 1 3 times. And I don't ever want to do things repeatedly. Anytime you're programming, if you're doing a particular operation more than once, there's probably a better way to do it. And this is a great example of that. So what we want to do is we want to try and figure out a way where, for whatever reason, again, the question might be find a location where it adds up to 21, in which case we're going to have to check all the different starting and stopping points looking for a 21. Or maybe the question is, what's the total of indexes 1 through 6? So in order to speed this up, and this is something that you can use in a lot of different problems, especially at the silver level, but I think I've run into a couple bronze problems as well where you can use this, although the official solution usually doesn't require it. But in silver problems especially, being able to analyze a subset of data and get some information for it. So what we want to do is we want to have a running total. So at the beginning, we start at 0. And then after adding the 3, our total would be 3, because 0 plus 3 is 3. After adding the 2, our total is going to be 5. After adding the 6, our total is 11. After adding the 3, our total would be 14. And what we're going to do is we're just going to keep adding the numbers as we go. After adding the 7, we'd be at 21. After the 1, we'd be at 22. And then we'd be at 25, 29, 31, 32, and then 36. Now, once we've done this, what we have for each of these, and this is an array essentially, you basically would put this in an array with a length 1 larger than your data set. What you have is for every single number, you have the value before adding that number, as well as the value after adding the number. And if you were to subtract these, 11 minus 5, that tells you how much you've added. So if I had 5 before adding the 6 and 11 after adding the 6, then if I do 11 minus 5, that's 6. That's pretty straightforward. But this goes across a larger range as well. So for example, right here, this 5 was the value before adding the 6. This 14 was the value after adding both the 6 and the 3, which means if I were to do 14 minus 5, I've got 9. And 9 is the total of 6 and 3. Now, the reason that works is because right here I've got 5. I added 6 to get 11, and I added 3 to get 14. So I've accumulated a total of 9 while going from the index before 6 to the index after 3. So what I then can do is I can do 14 minus 5 to get the total amount I added over the course of that range. Now, this works for a range of any size, with any starting point and any ending point. So earlier, I was asking, what's the total of indexes 1 through 6? This is index 1, 2, 3, 4, 5, and 6. So rather than doing 2 plus 6 plus 3 plus 7 plus 1 plus 3, I can take 25 minus 3, and I can see that the total of that is going to be 22. And we just want to double check that. I've got 2 plus 6 is 8, plus 3 is 11, plus 7 is 18, plus 1 is 19, plus 3 is 22. And that was the total I came up with 25 minus 3. Let's do one or two more of these things. Okay, let's say like I want to know the sum of the numbers 7 through 4. Then again, after adding the 4, my total was 29. Before adding the 7, it was 14. So if I do 29 minus 14, I'm going to get a total of 15. And if I do 7 plus 1, that's 8, plus 3 is 11, plus 4 is 15. So this has given us a way to very quickly add up, that was a 5, to add up a sequence of numbers within a range. Another use is, maybe the question is, are there any numbers that add up to some particular total? Like, let's say like I want to find something that adds up to 17. So rather than having to continuously be adding 3, 2, 6, 3, et cetera, and subtracting numbers, what I can do is I can look for any pair of these numbers that have a difference of 17. And from a programming standpoint, that is actually a lot faster because that's an n-squared algorithm rather than an n-cubed algorithm. So I'm looking for a difference of 17. If it was 3, then I would have a 20. I don't have any 20s. Difference of 5, then that would be, what is that, 22? 22, oh, I've got a 22 here. So that tells me that because I want to find a subset that adds up to 17 from here to here, because I have a 5 to start with, and I know that 17 plus 5 would be 22, all I have to do is locate a 22, and I can say, okay, well, these numbers must add up to 17, and we can double check that. 6 and 3 is 9, plus 7 is 16, plus 1 is 17. So not only do we have a very fast way to know the total of numbers in a sequence, we also now have a very fast way to try to find a set of numbers that adds up to a target. And you can do this with, you can do this with any combination, any numbers. One other thing that this is useful for, it's not just for adding up numbers. Let's say like we have trues and falses. For example, I might have true, false, true, true, false, false, true, false. And let's say like I want to know, for example, are there any trues or are there any falses in a range? Or actually there's a particular problem. Lonely Photos actually uses this. The official solution doesn't use the technique, but there are situations where you hit sequences where you want to know, is there a particular, like for example, it's like Holstein, Guernsey, Guernsey, Holstein, Guernsey, Guernsey, Holstein, Guernsey. We want to try and identify where can we find exactly one Holstein cow in a sequence of Guernseys, or vice versa. Anytime you have a sequence where something can be identified as a true or a false, or some sort of a binary choice, like Holstein versus Guernsey, you can use the same technique. And what you would do is you would count the true as a 1 and the false as a 0, or vice versa. So as of here, I have no trues. And then as of here, I have 1 true. As of here, I have 1 true, still only 1 true, still only 1 true. Here's 2 trues, still 2, still 2. Here's 3, and then still 3. So now if the question is, how many trues are there in the sequence from here to here, then again, I can just do 2 minus 1 and know that there's a single true in that range. It doesn't tell me where it is. It just tells me that there is, in fact, a true in that range. If I want to specifically look for sequences where there are no trues, then I just need to look for a sequence where the number doesn't increase. So from here, it starts and ends at 1, which tells me there's no trues in that range. If I want to try and find a sequence that contains 2 trues, then I can start with any number. And then if I want to find 2 trues, I just go until I get the first 3. And that tells me that there's 2 trues in that range. Again, and the technique is the same. If I want to know for a particular range how many trues there are, I get whatever the number is after the last part of the range, minus the first part of the range. In this case, 3 minus 1 equals 2, which tells me that in this range there are 2 trues, and they are here and here. So that's basically, that's all there is to a prefix sum. And again, this is a technique that you can use a lot. Anytime you have a linear sequence of data, we have a way now that we can look at the sequence of data, get the ending of a particular sequence minus the beginning of a particular sequence, and we know how much change has occurred through the course of getting from that starting point to the ending point. And then likewise, if we're looking for a particular target, you can actually binary search on the right side. I kind of glossed over that earlier. But if I wanted to find something that has a total of 17, then I can start from here and I can binary search this side to try and find my target. So if I'm trying to find something that adds up to 17, I'm looking for a 22, I can binary search this side and look for a 22. And then that'll give me the sequence that adds up to 17, or if there is no 22, that'll verify that there's no sequence starting from 5 that adds up to 17, and then I could move to the next number. So that's a prefix sum, and good luck with your coding.